Give me a few seconds. Okay, it should be live now. You guys can start. Thanks.
Hi, my name is Ashley Forey, and I am here to present to you today our brand new exciting course that is coming very, very soon, titled Pre-Engineering and Robotics Certification by Design. I am the instructional manager with our STEM CTL Center, Center of Teaching and Learning. I am the author behind this course. And I have my co-partner here, Andy, who will tell you where he is coming from.
Well, howdy all. I am from Texas, where we are headquartered, and I work for the Robotics Education and Competition Foundation. So the REC Foundation is most notably known for the VEX programs that we run on behalf of tens of thousands of teams throughout not just the United States, but the world. But we're the governing body. Part of that feedback was years ago, about a decade or more, a lot of the coaches happened to be in the classroom as well. And so they had curriculum, ITEEA curriculum, soon to be everyone having EBD for their pre-engineering and robotics. And they wanted a way to certify that body of knowledge the students obtained. And so we worked with college, industry, and those teachers to create a certification on the body of knowledge that Ashley's going to be talking about today. So my background is chemical engineering. For 10 years, I was an educator for 12 years, and I've been with the REC Foundation for about 6 years now.
So I'm going to dive into our presentation, and I'm going to walk you through what the STEM Center is, a little bit about our Engineering by Design program, and then we will get a first-hand look of behind the scenes of what this new program is going to entail for you. So you can get excited and you can be the first previewers of this new course. Our STEM Center, who we are, is our STEM Center for Teaching and Learning was established in 1998 to strengthen professional development in the advancement of technological literacy. The center initiates the directive towards 4 goals: development of standard-based curricula, teach enhancement, enrich research concerning teaching and learning, and curriculum implementation and diffusion. We pride ourselves at being standard-based curriculum. We believe that in unlocking children's untapped potential to shape future technologists, innovators, designers, and engineers. Our curricula inspire students to embrace challenges, learn from failures, and persist in problem solving. Teachers guide students to see an effort as the path to mastery, especially through the initiative engineering processes. So why EBD? Well, we incorporate active learning strategies. Our EBD and curricula engages students in hands-on, project-based activities that encourage collaboration, critical thinking, and creativity. It encourages teachers to use the inquiry-based learning where students explore and solve real-world problems using an engineering design processes. We also pride ourselves in the differentiation of our instruction. Our curricula supports teachers in adapting lessons to meet the diverse needs of students across all grade levels. It provides scaffolding techniques and flexible assessment tools to accommodate different learning styles and abilities, ensuring accessibility for all students. It also integrates cross-curricular connections. EBD curricula emphasizes the importance of linking integrative STEM concepts to other subjects like math, science, and literacy. It helps teachers deliver lessons that demonstrate how STEM knowledge applies in various fields, fostering interdisciplinary understanding and application. Again, I stated we pride ourselves at being standard aligned. We are standard aligned not only for the technological and engineering literacy standards, but also our next generation science standards, our Common Core math standards, our Common Core English Language Arts Standards, as well as the NEA's Grand Challenges for Engineering. We also pride ourselves in 2 delivery methods of our curriculum. We have our media-rich curriculum, which is delivered through our very own LMS system called Buzz. This contains pre- and post-assessment, videos, PowerPoint presentations, the whole guide a teacher needs to be proactive in the classroom to support their students' learning. Our LMS system is also able to be published to any other LMS system with our feature of Publish Anywhere. So if you are a school district coming to us today with the use of the LMS system of Schoology or Canvas, our curriculum is able to be delivered to your LMS system that you are comfortable with. We also have states, which we are proud to call our consortium states, who have access to our standard edition of our curriculum. This is where our curriculum is delivered in a PDF style to your school with hyperlinks to all of our resources. Before I get into our new class, I also want to explain that our curriculum scaffolds from pre-K all the way up through 12th grade. In our elementary renditions, our pre-K through 6th grade features 20 unique STEM lessons that are engineering-driven activities, provide engineering design process, literacy incorporation of vocabulary and spelling, math practices, presentation skills, community connection opportunities, and many more features. Our middle school consists of 6th through 8th grade 5-day lesson activities, followed by KSB knowledge skill units. Each of our KSB units focus on 5 lessons with a primary and a preliminary challenge. Our middle school curriculum, each grade level is assigned a different set of engineering-driven activities. Our high school has 9th through 12th grade curriculum, also begins with the first 5-day lessons, but they are followed by 3, 4, or 5 learning cycles. Inside the learning cycle, there are 5 lessons, a primary challenge, and a preliminary challenge. We also pride ourselves on our 6E Learning by Design. The 6E Learning by Design model offers our systematic approach for integrating the T and E of STEM into the classrooms, unifying design and equality to enhance both the technological literacy and next generation science standards. E for engage, the first one, means that we're going to pipe our students' interest and involve them in the lesson while assessing their prior understanding. Our students then will explore to allow them to construct their own understanding of the topic. Explain provides an opportunity for students to explain and refine their learning. Little E Engineer is to deepen the understanding by applying concepts to the design world. At ITEEA, we believe every individual can engineer. Enrich enables students to explore concepts in more depth and apply them to complex problems. And evaluate helps both the students and the teacher assess learning and understanding. So inside all of our lessons and our units, you will be provided with the lesson plan that is arranged in the 6E style. Our high school curriculum immerses students in comprehensive STEM education covering technological concepts and processes, programming and computer science and engineering technological literacy. Students engage in creative and innovative activities, explore specialized fields like cybersecurity, biotechnology, and robotics, and develop problem-solving skills through sophisticated engineering design tasks. All of our high school courses include modeling, assembly, and engineering drawing challenges, preparing students for certification exams, and fostering collaborative design skills. It equips students with essential STEM knowledge and inspires them to lead and innovate in a technological world. Our courseware are 36-week semester-long delivery, but our certification courses are 18 weeks, so they can be utilized inside your time frame of a school year. So let's talk about this new certification. It's what we're here for. Our pre-engineering certification is going to be coming soon. When I say coming soon, our launching standpoint at this time frame is to be February, meaning that we are hoping to have a cohort of teachers that want to pilot this class with us in our February duration of our Scholastics cohort. OnShape has ran the last 3 years during this time frame. Now we are bringing in one more. The Engineering by Design Industrial Certification Pathway will soon offer this high school course in Pre-Engineering and Robotics. This 18-week course covers robotics, aerospace, chemical, civil, electrical engineering, as well as computer science programming and manufacturing technology. Students will master the skills needed to take the RC or Rec Foundation certification, I was going to abbreviate it, a certification exam and become industrial certified before graduation. The images you see on the slide are some of the examples of what your students will be creating, not only in OnShape, but also can create with Vex. So Andy is going to talk to you about this pre-engineering robotics certification.
Yeah, well, howdy everybody, and thanks, Ashley. I'm super excited. I will say I got a sneak peek or two to the EBD curriculum for this, and it is spot on. And worry not, if you don't have Vex equipment, you can still do the whole EBD curriculum, which is one of the things that we work together on to make sure it's almost like classroom agnostic, right? We want you as the educator to be able to use the tools in your classroom to teach, not necessarily the tools on a website. So what this certification is it's pre-engineering and robotics certification. Our goal is that students leave high school with a body of knowledge that's now certified, whether they decide to go straight into industry after their 12th grade, 18 years old, or they decide to go into a 2-year technical school, or they decide to go into a 4-year degree. All of these will serve them as, if nothing else, a resume builder, but more importantly, as a testament to what they've learned. So click, or do I click? I don't. So at the REC Foundation, I just want to make sure that's understood that our mission is to provide every educator what they need to allow their students to have engagement in STEM. Notice that our mission is not about the students themselves, because we know that the conduit to the students is actually the adult in the room. And so by giving every educator access to the industry certifications, in essence, we're giving the students access to be able to support their STEM careers. Going to the next slide, just to talk about the certification itself. There are 2 different industry certifications available. There's one for engineering. It's called the pre-engineering certification, and there's another one for robotics. And the idea being that after you complete engineering by design, you'd be able to do, based on the choices you selected while teaching that, you'd be able to certify your students in both or either. They are what's called stackable, so that way if you do receive the robotics certification, you receive the robotics certification and the pre-engineering certification at the same time, which is a really good deal if you're in a state that incentivizes students getting certifications. If you can go to the next slide, we are accountable. So we periodically review. This is why we are approved on the 15 states that we'll show you in a minute. And the reason we're certified is because we don't just have a set of test questions that we created 10 years ago and sit on that. Every summer, we meet with ITEEA. They review the test questions. We meet with industry, and we meet with colleges and high school teachers, and we're constantly updating that knowledge and occupational skills document, as well as making sure we have alignment in the questions that's being asked and the industry that is hiring, because nobody wants to hire someone that's great at a mechanical typewriter anymore. So why have those questions in there? We really need to be getting further into advanced manufacturing robotics. That's where the future of careers are. So right now, we are fully approved in 15 states, and you can see them here. We're working to get more. It might be surprising to find how difficult it is. If you are in Department of Education, you can maybe give me a ring if you don't see your state up there, or in some cases, like in Texas, where we're headquartered, you notice that we're still not fully vetted by the state of Texas, because the Texas Workforce Commission is the one that does the approvals for industry-based certifications in the state of Texas. So every state, all 50 states, has a different criteria, a different process. So we're working through those to make sure your students have a place to get recognized. I know that there is a chat and that it is being monitored. So if you have questions, please put those questions in the chat, or at the end, we'll have a Q&A session that we can all jump together and maybe hash it out live. The benefits, the reason why we feel confident that the students that take this test and pass it walk away with benefits for the rest of their lives is primarily the workforce development before they're even graduating high school. Now, this certification is available for folks after high school as well. We do have some 2-year community college or 2-year technical schools that use this certification as well, but the core design factor of students is high school. They walk away with industry knowledge. Also, it prepares them for whatever they do in the future, as we said previously. But for you teachers out there, and you administrators, and you Department of Ed folks, the #1 reason industry-based certifications are becoming more and more prevalent and more essential to our students' success is that it gives validation to what the educators are doing in the classroom, their body of knowledge and their skills. So how do you do this? How do we get this into your classroom? How do we give this as an opportunity? Well, you're familiar with Perkins funding, I'm sure. If not, you can reach out to us, and our email will be on the last slide. It's just certifications@recf.org. But what we're really doing is allowing your students to get access to funds, giving them industry recruitment, and maybe even earning college credits. Now, that's a bit of a stretch because most certifications, and rightfully so, don't correlate exactly to college classes or college credits. It's even better than that. They correlate to industry knowledge, which is sometimes very unique between the theoretical, philosophical stuff and the applicable stuff we're learning in college versus the practical stuff that you get in your career. So how do you do this? How does a student do it? Well, there's 2 different pathways. The pathway to pre-engineering, I think, yeah, we might have skipped a couple things. Let me just take one step back. The certifications themselves have, you can go ahead and go forward, is everyone must pass fundamentals of engineering. That is a kind of a blanket intro to engineering course. Like Ashley said, Engineering by Design is going to check all of those boxes that are available in fundamentals of engineering. And then once that's passed, your student, with your help, of course, with your guidance, is going to take 2 to 3 of these modules that you see listed below. There's 8 of them total. So for instance, if you are teaching an aerospace unit, you would naturally gravitate your students towards taking the aerospace module. I will go ahead and just, while I'm on this slide, pivot to say that for robotics, specifically for the robotics certification, you are required, you don't get to choose, you are required to take the mechanical, the electrical, and the computer science and engineering programming modules. So you take the fundamentals and then those 3, and that right there is your robotics industry cert once you've passed those 4, once the students pass those 4. Okay? And let me break that down a little bit better in the next slide. So again, for pre-engineering, all tests require 70% or higher. They're 90-minute exams. It's at approximately 100 questions. That's all for that fundamentals of engineering. And then after they pass that, they have to pass 2 self-selected, user-selected modules with, again, 70% or higher. Now, this is a shorter exam. It's only 30 minutes long, and there's about 25 to 30 questions for those. So again, of those 8, that student chooses 2 after passing the fundamentals of engineering, and they walk away with a pre-engineering certification. The next one is robotics. Same thing at the top. You pass the fundamentals of engineering, but then you pass 3 specific module tests. Now, this is where the stackability comes in for those of you that are savvy enough to say, oh, wait, if I'm passing 3 of the tests, well, that inherently makes me having passed 2 of the pre-engineering certification test. And you're correct. When someone receives the robotics certification, they're actually receiving both, which if you think about an industry, that's exactly what a robotics person would be doing. They would also be obtaining some pre-engineering level of knowledge. There's some great quotes there at the bottom. Feel free to use them. But otherwise, I'll pause in case any questions are available and you're typing. And I'm going to turn it back over to Ashley.
All right, so I took one of the lessons to give you a deep dive look today at what it utilizes. I guess I could have kept this full screen, but I'm going to actually jump into the actual presentations, and I unlinked this for my own well-being, I guess. But this was one of the primary challenges from our Unit 1. So our certification by design course is going to basically mirror our Onshape certification course in that you will have a first 5-day activity with your students to get to know them, to build rigor, to find out their developmental background. And then from there, you will have 3 units. The first unit is on mechanical engineering. The second unit focuses on electrical engineering. And the last unit focuses on, could you get that? The robotics platform with the programming applications. So as we explained, if you take that robotics certification exam, you kind of get to kill 2 birds with 1 stone for that pre-engineering aspect. Now, the pre-engineering aspect is embedded throughout everything. For example, one of the pre-engineering concepts is that engineering design process. That's going to be brought up in many, many different lessons because your students are going to experience that more than 1 time throughout their units. But I'm going to hop us into, like I said, our primary challenge of Unit 1, which is building a gear train on a windmill, which sounds super, super exciting. So the PowerPoint presentation, this one, is the inside look. It's not perfected. It's not perfect. It hasn't gone through editing times 14 people, but again, it will give you an idea and a feel of how this is going to look from the engineering by design standpoint. So the engineering by design gear train comes up with the big idea. Your students are learning about what is renewable energy and what is non-renewable energy, because why not talk about that when you're building a windmill? We then have them engage in the different types of windmills. Horizontal axis windmills, vertical windmills, how they work, the different directions. And these are actual windmills that you guys may find in your community. They then continue learning about the engagement of windmills, of whether they're land windmills or they're ocean windmills, or if they're windmills that are for a small residential place or a big industrial application. They have a video that is linked in here from the actual U.S. Department of Energy explaining how a windmill actually works, because we have to get their mind thinking, because in the end of this whole program, they are going to be building a windmill that's broken and they have to learn how to fix it. Your students are given a windmill worksheet to explore windmills with a simulation. They actually have to figure out how to use the simulator for a land-based gearbox turbine as well as an offshore turbine. The simulator comes from us from the U.S. Department of Energy, and it gives them a great experience. There's also questions thrown out through your PowerPoint to get them thinking more mathematically. One of the biggest features with our Rec Foundation is how much math and science and English literacy is incorporated into these assessments. So by giving your students experience with the type of questions and the way things are perceived and said, hopefully will help them generate enough concepts and knowledge to be able to pass these mathematical equations on that certification exam. Because we're talking about a gear train that's broken on a windmill, of course, we're going to talk about gear ratio. Again, you have to explain and have your students explain how to calculate gear ratios. They will have a worksheet activity to check for understanding, to apply the details. This is your teaching tool, and in return, your students will give you your feedback. We throw in, the different concepts, adding idler gears. We talk about how to add speed, RPM. And then your students are going to practice and gain their knowledge, not only on their own, but as a group. And then they can collaborate on their skills again to scaffold their learning and understand how to do many of these calculations with gear trains in this case. Your students then get to utilize Onshape. Now, for those of you who are like, oh my gosh, I have to go experience Onshape, this is going to be really a challenge for me. Everything that is done in Onshape is assembly based. Onshape has created the Vex. I have a little icon right here in the video. Has created a Vex platform for you where all the parts and pieces are pre-drawn, pre-made. They come with plans, and all your students have to learn in Onshape, which is one of the lessons, is how to fit pieces together. Now, from an educator to an educator, you are provided with video feedback, video support. This video actually comes with a narration for you as an educator. This is the first step. This is the second step. You're assembling the gear train to try to actually make it work. And you're given the actual files from Onshape to manipulate with your own classroom. So you also have all the answer keys. You get to try it out on yourself. When updates come up, I have to push a button and I have to update it on my side because Onshape is always updating their iCloud and their platform. And then you automatically get the updates. So it's a very cool, very user-friendly approach to using Onshape. So if you're thinking in the background, oh my gosh, I have to get my Onshape certification in order to do this. Nope, you don't have to. You can, but you don't have to. Everything is guided for your students and for yourself, which is what we pride ourselves in with our professional learning here at ITEEA. So, your students also have a career outlook connection many times throughout this activity because in the real world, that is what they're doing is working for an industrial certification in a career field. So this is talking about if I was going to work with the energy industry, what kind of jobs would I look for? What's happening right now in this time? What plans are up in the future? As you see there, there's a law that's coming in effect for clean energy by 2035. And then 2050, having a zero net carbon. We know things change time to time, but this is real life, real future. What is happening now? We also pride ourselves at not making things from the old. As we said, as Andy said, we don't want to teach what a typewriter uses. We want to know how to do actual computer coding on an actual machine of our era. So this is also looking up for that future and what the possibilities are. And then enriched with vocabulary and enriched with extensions. All of that is here for you. But this is one of those lessons that your students can be enticed with. I wanted to just come show you, here's the inside look for the student platform or for the teacher platform. You have the fix it. So they also have a kind of a choice option. You could have your students only fix the windmill because it's broken. You could have your students have all the parts separated and they actually have to go in and attach all of the parts and pieces together or part of it because it's not going to work the way it is. or you can have them make it and fix it. So it's broken and it needs to be fixed. So you can scaffold your students' learning. That was another prod thing that we do at ITEEA, is make sure that we have a bunch of different iterations for you depending on who your students are with you in the classroom. You are also provided with the answer keys and the STL files. Now, you probably saw back on this PowerPoint, you were probably wondering what was going on with this image. Now, I'm going to hit present, and I thought, there it goes. You probably were wondering what, maybe it was on the other one. Oh, it was back a slide. I remember, because I saw it and I was like, I wonder why I put that image on there. Probably saw this image. We'll make it bigger. So you're probably wondering what this is, okay? This is the windmill built with Vex. This is the windmill printed on a 3D printer. Yes, many of our activities also allow you to do some rapid prototyping, because that again is a new age invention and device that many of us find user-friendly and exciting to have in our classroom. Now, of course, this is going to be multiple parts, a big duration of time, but it was really kind of fun to print on a 3D printer. Your students also will build a gear train. That's another example of a project that could be done on a 3D printer. So not only are you learning how to use some of the features of Onshape and the tools of Onshape for this, you also have applications to rapid prototyping through this curriculum as well. Make it fun, make it exciting, make it also more than just robotics, because everything on the certification is also more than robotics. As we stated at the beginning, we have content for civil engineering, architectural engineering, graphic design, 3D modeling. Like, there is so many industrial applications that apply to this Rec Foundation credential. So we're giving you all the experience that you need. So a few other things to take away about our curriculum. Our curriculum integrates the existing engineering technology education STEM program, or to start a new one. It can be used either way. As we explained, this is an 18-week course, so it could be used as its very own 18-week course delivery. You could also seamlessly have a semester of this and a semester of Onshape, and you could have 3 certifications at your fingertips. This is also a course that could be embedded through multiple lessons. We are trying to figure out at ITEEA what those 3 courses were. If you are familiar with our Onshape certification, we have it embedded in like our 10th grade course, an 11th grade course, and a 12th grade course. So over the 3 years, they're able to gain the knowledge and the scaffolding of the curriculum to heighten and advance, I guess, their knowledge in the areas for that certification exam. We are hoping to be able to do the same thing with this, but tying it more with our computer science application courseware. So we could see this being a potential growth experience for our principals, our computer principals class, having a unit from here in that. So if computer science is an area of weakness for one of your students, they're not very good at programming, they could excel at more development in computer science with that course, and then embedding some of the content from here, one of the units from here. So as they grow from 10th, 11th, and 12th grade, by the time they're done, they can be ready for their certification exam. Professional learnings. We deliver professional learnings to ensure that teachers like you receive comprehensive training on all of our Engineering by Design curriculum and STEM teaching methods. This can include an in-person training or a virtual training, a just-in-time mentoring training, and an asynchronous coursework training, which I'll explain here more in a moment. We also pride ourselves at our virtual conference and in our in-person conferences, the opportunity to do some hands-on activities with us and get some professional learning that way, which is why you're here today. Resource allocations is to provide all the necessary resources, such as materials for the hands-on projects, technology and engineering equipment, access to labs or makerspace. This supports practical application for STEM concepts. We also have collaborative learning. We foster a collaborative learning environment where students can work in teams to solve real-world problems. I always tell my students, my 6th through 8th graders, that I don't know any engineer that sits in a cubicle and waits for answers to just come on a computer screen. They actually have to work in a team to solve the real problems that are in front of them. This encourages for our students critical thinking, creativity, and of course, communication skills. We also pride ourselves in making sure that our curriculum has community partnerships. So not only do we have the Rec Foundation, we also have Onshape working with us for our community partnerships. We also ask you guys in many of our lessons to reach out to businesses around you, universities, and STEM organizations to provide additional resources, mentorship opportunities, and real-world insights. Through our curriculum, we also approach it with assessment opportunities. Giving continuous assessment methods to monitor your students' process and adjust the program as needed is what we want you to do. This could include our project-based assessments, making student portfolios, and also having regular feedback sessions with your students. And parent involvement. We pride ourselves in opportunities for your parents to be informed in the activities that you're doing in the classroom. Encourage them to get involved in your projects, have school events to share what it's like to be this engineer, and have a creative, supportive learning environment community for your STEM students. So back to that professional development learning. We have 4 opportunities of learning all of our curriculum or some of our curriculum. It depends, I guess, on the course. Many of our courses come with the first 3. We provide in-person training for your school, yourself, your school district, and or your state. What this can look like is your district, state, or yourself request an in-person training session. Our national authentic effectiveness teacher coaches and or our in-state coaches will be by your side to walk you through in a duration of a couple days to a week what that course or what the course looks like in detail. We also provide a virtual training where it's very similar to this, computer style. We do a Zoom, we get you acclimated to the courseware, we walk you through a session, but it's all virtual, comfortable from your own couch. We also provide mentoring. What this means is we all have had those teachers that get the job at the last moment. School starts tomorrow and oh no, what are we going to do? We are here to provide mentoring in all of our courseware for those teachers. And asynchronous learning. Asynchronous learning just launched this year with our Onshape certification byDesign course. It is a self-paced course, which includes, again, the 3 units, 5 learning cycles, and 2 challenges. The Onshape educators use the Onshape and ITEEA Buzz learning management system to complete activities. We submit a portfolio for review to receive a certification of completion. This course is ideal for educators wanting to use Onshape in their classrooms, teaching it to students, learn about the Certification Association exam, and also become certified yourself. It can be started at any time and completed in about 40 hours of your own convenience. You also have the opportunity to receive grad credits at an additional fee, which I will talk about here in a second. This Onshape certification course is already active. It launched in August. You may have gotten some ITEEA flyers to let you know about it. That QR code will bring you into the beautiful application to sign up. We have 12 instructors who are being students in our courseware. I am watching from the background, being the instructional manager and helping and support. It is so fun to see. We have some educators who are already at Unit 2. We have some educators who are just signed up waiting for winter break because that's when they're going to hit those 40 hours. It is completely at your own pace. All the videos are pre-recorded and all the information is there. And you just work on it when you are wanting to work on it. We have ran 3 in-person cohorts over the last 3 years. I think we have our eyes on the horizon to do it again this year for an in-person session. So just watch your emails for those flyers and pamphlets. But this course is there for you to start your professional learning today. Grad credits, let's speak about that. Yes, all of our in-person, all of our virtual, all of our asynchronous, including this new course, are fully accredited and approved from St. Cloud State University to receive 3 semester grad credits, an additional cost of $500. St. Cloud State University in the great state of Minnesota has recognized engineering by design to be a very well appreciated curriculum internationally, and have decided to offer this opportunity to all of our instructors who complete our professional learning trainings with us. You basically sign up as a non-seeking degree student at the completion of your certification. You pay the school, the university, $500. They grade you a letter grade of an A, and you receive 3 grad credits from them for you to put into your record bank. St. Cloud State University also has a technology and education, or technology and engineering master's program that if you would want to continue more educational training from them, you certainly could as well, utilizing these 3 credits towards that degree. Coming soon! Yes, okay. So after the in-person launch of this beautiful, amazing new course, it will become a professional asynchronous learning style for you as well. So not only will you be able to have a live person teach you and train you when you need that, or if you need that, we will have it running as asynchronously as well. This is because Onshape is iCloud based and is able to be asynchronous. So a very cool feature of having everything being able to be on the internet is being able to give it to you as an asynchronous delivery. We also have some other courses in the future in our horizon that are in talks right now to look forward to. Engineering Tech Ed Lab Safety by Design. Oh yes, we know that wood shop still scares some of us, and we want to know the ins and outs of everything and be prepared for those students. So that Engineering by Design course in safety will be coming very soon, as well as Learning by Evaluating, Soft Robotics by Design, and STEM Methods by Design are a few of the courses that we are very proud to get our hands on and get created for you guys in the field. A few other things that we want to take a moment to talk about is our research. The NSF POSE grant supported by ITEEA and creating an educational CAD model program library for K through 12 schools. The website is listed right there. This library extends peer review on CAD models, encouraging design alignment with K through 12 standards. Unlike other modules or platforms, it really focuses on the K through 12 education and requires peers to review the models. So if you are an educator who wants to try some new lesson plans that other educators across the nation have come up with, take a look at this website, give them some feedback, pilot some of the lessons, and see how you like them. They're in science, they're in engineering, they're in technology, they're in mathematics, and they're in language arts. So there are many different applications that you can look at from that POSE research. We also have the DRK-12, Learning by Evaluating, which is to prepare students' design by the critical thinking and ability to design ideas. This compares peers' previous work to identify which one is better and for them to explain their reasoning. We all know we have those students that create something and then they compare it to someone else and they can't explain why one is better than the other. This research is funded from Purdue, UGA, BYU, and ITEEA, and is also funded by the National Science Foundation. And the idea is that it's supposed to help our teacher lead to help them. Wow, I can talk. This is a teacher-led debrief that helps them recognize the patterns, initializing expectations of their own work. So getting your students to think more of, done, now what? The next assignment. It's to evaluate and compare to other solutions. The Excite program is also on our PowerPoint presentation, which is a very exciting announcement for you guys to sign up for. Our Excite 2 is initiating from our NSF funded partnership and led by ITEEA in conjunction with Hofstra and North Carolina State University. This course is a high school program that is board certified for placement 1 level computer science principles course. The course is launched, the course is running, but the course needs more states to come pilot our cohort 2. This summer, we have a group of trainers ready to roll who are looking for teachers in North Carolina, New Jersey, Georgia, Pennsylvania, Delaware, Idaho, Kentucky, Minnesota, Missouri. There's a few others on that list. That's the QR code. But they are looking for more states to come pilot this computer science principles. Reading that flyer, information is there for you. The funding from NSF, the partnership, it is an amazing opportunity to get computer science into your class. Of course, it's an engineering by design curriculum backed up Buzz platform, ready to roll assessment. And we had Excite 1 that finished last summer for our high school students program. Our curriculum implementation and diffusion. So our curriculum professional learning and research systematically meshes, and our curriculum is authored by field experts and piloted in STEM classrooms. Yes. So as I stated, I'm the author for this pre-robotics and engineering course. My full-time job is a 6th through 8th grade middle school technology and engineering teacher. And I teach app creations, I teach robotics, I teach CAD modeling and design, I teach biomedical engineering, I teach electricity and programming and digital graphics and design. And as most technology and education teachers, like several preps to 8 preps in a year. And all my curriculum that I've created, I pilot on my students. I get to see their faces, their expressions, their excitements. I find out what doesn't work, what does work, because that is what we pride ourselves in, is having our curriculum actually in the hands of students before we actually put it in the hands to other teachers. We value their feedback. Now, yes, I did say middle school, but I have been in high school here and there. I have done graphic design, electrical engineering, as well as digital art graphic design in high school over the course of the last 15 years of me being a teacher. So all of our curriculum from pre-K all the way through 12th grade, before it actually gets on the Buzz platform, it is actually implemented and piloted by students. A few last things of this PowerPoint are for you as an educator. Some other things that we require or want you to take a look at because we are proud of you as educators. At the STEM CTL, we have our STEM School of Excellence, which is to recognize your school for your outstanding commitment to providing a robust, integrative STEM education experience through the STEM School of Excellence Recognition Program. All K through 12 schools, colleges, and universities are able to apply. That QR code right there can get you the link to sign up. We would love to honor and award you at our in-person conference this April with your STEM School of Excellence plaque. So please share with us, what are you doing behind the scenes? What is your STEM school look like? It is so fun to see them every single year up on the big screen. You're inside of your classrooms. The other one I have up here is also our Reach Challenge. If you are finding that you need some more curriculum to do or some more excitement in your room, This is our impactful adaptive and assistive technology design thinking project for all middle schools, high schools, and colleges, showcasing the missions of that technology and engineering bring STEM to life. Teachers are provided with a toolkit of curriculum and resources to lead their students to create a viable, adaptive, or assisted technological solution to help someone in their community. Projects can be submitted to ITEEA for the opportunity to receive awards for your adaptive and assistive programming. I'm going to take a moment here to pause, and I'm going to have you click that QR code right there with your lovely device. This is able to request more information about this new program, as well as any information that you may have from our STEM Center on any of our curriculum that we have for you. This form is a Google form. This is just a way for us to connect back to you if anything comes up after today's presentation of question and answer. And if you need us in the future. I do have a question that is sitting in the question and answer. I can see it there. Are students required to take any prerequisites? No, they are not. So the very first 5 days is actually understanding the Industrial Revolution and the history of engineering, which is what entices and started this whole exciting pathway of experiences. It is also very well scaffolded through all the different levels of engineering, from civil to construction to manufacturing to mechanical. And so any prior, technology courses that they've taken, yeah, we'll give them a little leg up in understanding, but you can have that brand new, have never held a hammer in their hand student sitting in front of you, and they will be able to excel at this engineering by design course.
Would you agree though that algebra would probably be a prerequisite for the course?
Well, and that's, I guess I should say that would probably be a thing. Most schools, and I guess it would depend on your school district, most schools, I would say algebra is probably a middle school level math course. I mean, my
Yes,
eighth
I
graders are in
agree.
algebra.
Yeah.
So I think in high school, like, they should have already a strong enough foundation to handle this. I am not a pro math teacher, but I can do division, and a lot of our calculations and a lot of our formulas are division or multiplication type of logical thinking. So
I would
yeah, I
say
mean,
my experience in teaching engineering, and not exactly this curriculum, but similar curriculum, is that having a background or having taken physics as a class definitely helps. But again, that's a theoretical, whereas this class is going to teach practical through like engineering based, project based learning. So yeah,
and
to
you're
Ashley's
provided with
point,
all the formulas.
exactly.
So
All the formulas are provided.
you're not going blind. But yes, I mean, just like with everything in the past, like if your students have come in with prior experience, they're just a little bit advanced in their knowledge. But you are going to have students that are going to come to you that are brand new and have never experienced things, and they're going to be just fine as well. So yeah, no, that was a great question. If you have any more, feel free to add them into your chat, and we'd love to answer them. The last slide I have for you before we finish our presentation is this one. And you can scan that QR code too. What that's going to do is bring you to our ITEA.org website, where you can experience the Engineering by Design platform. You can look at pricing. You can look to see if your state is a consortium state. Mark Harrell is the STEM Center Director. He is, I guess, my boss above me. He works more with the curriculum, the directors in the state, where I work with the curriculum and the EBD. But his information is there too. And when you can send him an email, and he will be more than happy to answer questions for you as well. And then, of course, Andy is on here with the Rec Foundation. So if there's any questions for him, his email contact is there as well. I'm going to just show you one more thing that I wanted to pull up here. When you can Google search this, but if you have any more knowledge that you need or any more information about these certifications, the Rec Foundation does have their industrial certifications information up on their website. It talks about all the pre-engineering areas. It talks about the robotics modules, talks about that occupational skills knowledge that your students will be needing for this assessment. And all of, like I said, our engineering by design curriculum is geared for all of these different scenarios and will benefit your students to be able to pass and complete these certification exams. So that is there for you. I hope you guys found some excitement in today's activities. Again, if you have any questions, feel free to drop them. I'm going to put this back up here so you can get some excitement. I love this lesson. Otherwise, I don't think I have anything else.
All righty. Thank you so much, Ashley and Andy. I'm not seeing any more questions at this point. I do have one. It's a comment and then it'll become a question. And that is dealing with the professional learning that you offered in this and how it's going to come out. I'm assuming when it's ready, it's going to be marketed and shot out there in a variety of ways, right?
Yes, great question. So, our plan here at ITEEA is actually to have this be one of the cohort learnings for spring. So, Onshape certification by design has been a cohort running for the last 3 years. That is not going away as of right now. We are actually hoping to run 2 different cohorts depending on our NTEX availabilities. But there could be an opportunity that Onshape will still run, and then we will be adding this as well. So watch your emails. The announcement will come around December of what's all going to happen this spring. But yes, it will be ready to roll this spring for either spring delivery on Mondays and Wednesdays, which is the cohort, and or full professional development learning starting summer. So it is good. It is golden. It is coming 2025.
Sounds great.
2025. It is here. We are very excited.
All right. I don't
So,
see
and
any
we
other
will need
questions.
pilot teachers.
Any other comments? Andy, anything else on your side?
No, thank you, and appreciate the opportunity to share about the certification. And if you have questions about that, you can reach me at andy@recf.org or go to the website that Ashley shared. So I really appreciate this, and I really appreciate what ITEA is doing to help bring this certification down to the ITEA schools, giving this as an opportunity. It really is. It's fantastic. And again, I got to see a sneak peek, and you're all going to want to check it out in 2025.
All righty.
All right. Have a great
thank you
night,
so much.
everybody.
Yeah, thanks so much, guys.
Thank you all.
I'm going to stop the live stream. I'm going to need a few seconds. Just hold still and I'll